Today's notes are in lesson 9.4, which is on the quadratic formula. I've written the standard form up above, and then I've also written the quadratic formula here. So go ahead and take some time to copy that down. So this is your quadratic formula. And then I highlighted the part on the inside because this is called the discriminant. Okay, these letters B, A, and C all come from our standard form. So our discriminant is helpful because it tells us, just like when we were square rooting positive numbers, negative numbers, or zero, it tells us how many solutions there are. So if the discriminant is positive, okay, meaning I simplify what's on the inside of the radical, which is this, and I get a positive value, then I'm going to have two solutions. If it is 0, then I end up with one solution. And if it is negative, then I end up with no real solutions. And let's quickly go over what does that mean to their graph. So two solutions means that the graph could be going like this, meaning it crosses twice. Or it could be going down, where it still crosses twice. One solution, the graph just means that it's on the vertex, is on the x-axis, and it could also be opening down, okay? These are going to be more affected by an a value that's positive versus an a value that's negative. My a value is positive, my a value is negative. And then no real solutions means that it's opening away from the x-axis. So this would be an a value that's negative. Or it's opening up, which means a value is positive, but it never touches the x-axis. Okay, so we're going to do two examples, and we're just going to practice using the formula and determining how many solutions we have. So first we need to make sure that it is in standard form. So I'm going to add 3 to both sides, so I get 2x squared minus 5x plus 3 equals 0. And then I'm going to figure out what are my A, B, and C values. So A is going to be 2. B is going to be negative 5, and C is going to be 3. And then I can use the formula where x equals negative b, so that would be opposite of that is 5, plus or minus the square root of b squared is 25, minus 4 times a times c all over 2a. And make sure that you include this whole thing inside the radical. So now let's go ahead and simplify just the discriminant. So our discriminant would be 25 minus, well, 4 times 2 is 8, times 3 is 24. So my discriminant is 1. So x equals 5 plus or minus the square root of 1 all over, oh, let's see, that's not supposed to be 2 times a, that's 2 times 2, which is 4. Okay, so because this is a positive value, I'm going to have two solutions. All right, now the square root of 1 is just 1, so we can say that x equals 5 plus or minus 1 over 4. And then we can keep going and say, well, 5 plus 1 is 6 over 4, and then 5 minus 1 is 4 over 4. And those reduce to give me x is, these reduce by 2 to give me 3 halves. And then also x is 4 over 4 is 1. So these are my two solutions. Okay, on to another problem. Again, we need it in standard form, so I'm going to add 25 to both sides. And then we can say that A, B, and C, we have 4, 20, and 25. They're all positive this time. And so the x equals negative b, so 20, negative 20, plus or minus the square root of b squared, which is 400, minus 4, and then a is 4 as well, and c is 25. This is all inside, all over 2 times my a is 4. So again, let's go ahead and figure out what is our discriminant. And so that's going to be, our discriminant is 400 minus, well, 4 times 25 is 100, times 4 is also 400. So this is 0, which means I only have one solution. So x equals negative 20 plus or minus the square root of 0 all over 8. Now the square root of 0 is just 0, and if I add that or subtract that, that doesn't change. So x is really just negative 20 over 8, which can simplify so that we get x equals negative 5 over 2 or negative 2.5. Take your pick. Okay. One last example that we are going to do comes from the textbook. And I just want to quickly explain. So we have a word problem here, and let's go ahead and do this. Okay, so if it's telling us that y is the number of wolf breeding pairs and x is years. So, and it's got this equation. Okay, when, so we're solving for x, were there about 30 breeding pairs. So that means that y is 30. So if I plug 30 in for y, then I get this equation. And the next thing that we need to do is subtract 30 so that this equals 0 and it's in standard form. Okay, then I can identify my A, B, and C values from this, and I can use the quadratic formula to solve. Okay. That's it for today. Let me know what questions you have when you're in class.